I thought the most productive use of our time today might be to go back to iRT, which we started on Monday. Is there anybody who wasn't here on Monday? Okay, well we got a good group then. So yeah, because what we did on Monday was really training a standard, which probably the majority of you would end up using. I mean, we just used, there's a set of known standards, all of which Skyline supports. And if you're using C18 chromatography, then the existing standards and their trainings will work just fine. We also sort of do more auto training. And so, yeah, if you're not involved in, if you don't want to try to train an endogenous standard or use your own heavy labeled peptides as your iRT standard, then you probably won't do what we did the first time. So I thought, this being a Skyjam and all, maybe we could actually try something that I've never tried before, so we'll see how it goes. So let's see, so in documents, we've got this iRT folder, right? Does everybody have that? Okay, so if you go to your documents folder, your iRT folder, so we've got this, this training skid file, which we've already sort of set up, but I thought we would start fresh and see how that goes. Because then this will be, so you've gone through the steps of, okay, here's how you train an iRT standard. Now let's just start. It's like we'll start from, you injected your iRT standard into your samples, and now you want to do the normal steps of training your own peptides to the standards. So we could either pick up with the document that we have used so far, which we've pretended we didn't know anything about these Biognosis iRT standards and we're training our own. But we could also, now we could just switch modes and say, oh, let's pretend that we know all about the iRT, the Biognosis standards, and we just want to train our own peptides. So let's try that. So if we go to Skyline, blank document, and we just go to our settings, peptide settings, and I guess actually before we do that, I'll have everybody, just so that we're all, make sure we're all on the same page, switch back to settings default again. So just choose settings default and no, you don't save your old settings. And then now if we go to peptide settings, and we say we're gonna add a new retention time calculator. Should we do that? Sure. Add a new retention time calculator, and we'll just call this Biognosis human. So this is going to be a calculator where the standard is the Biognosis set and it's human, and we're going to click the create button like we did last time and navigate to documents iRT, and we'll call this be human. And save. And that again just creates an empty iRT calculator. And then we're just going to choose that we'll use the Biognosis 11 peptides. Right? And that gives us the iRT values that Biognosis chose for their own standard. And then we click OK. People following? Click OK. And Skyline now automatically creates a retention time predictor based on that. And then we click OK again. And now Skyline will ask us, hey, the document doesn't contain these iRT standards. Would you like to add them to the document? And we'll just say yes. And you get to choose how many transitions per peptide you want. And in DIA experiments, often we would go up to 6, but we'll leave it down at 3 right now for this SRM experiment. And now the one thing I'm not totally positive of is whether these 3 that we've chosen here are the same as the 3 that we had in our other document. So I'm not totally positive that these 3 transitions are exactly the 3 transitions that were measured by Biognosis in their experiment. So that's the one thing where I'm like, I don't know how this is going to work out. So we'll see. And then, oh yeah, this is not.
It's not the official transitions.
Not the official transitions?
No.
Okay. So you recognize them pretty well, huh?
I have the iRT reference sheet on split tile.
Oh, okay. All right. Well, let's. So yeah, I think we measured them. It looks like we measured them with we measured them ourselves and chose transitions based on the spectra that we got, I guess. All right. Well, let's actually start over because I realize that there's something else that we would like to do. So you can just, I think you can just forget about that right for the moment. And we're going to open the file with the peptides we want to work with. So do you want to save changes? No. And let's open this iRT human. So this is our set of peptides which we've measured. And so let's call this, before we start working with this file, let's just save as to a new file and call it iRT human training. And then, so you can see that these have heavy and light pairs, which is what we want to measure quantitatively in the end. But for training, which did they measure? Well, okay, we better import some data into this. Let me quickly import some data and then okay, so they measured the endogenous peptides. Okay. So all right, so to get a measurement, so first to get a measurement of these peptides, we're going to measure them in, without chromatography. We don't know where they're going to show up. And we're only going to measure one type because, if we have 1,198 transitions, that would take us, if we did file, export, transition list, and again, we said we were going to do multiple methods. If we can measure 200, it's going to take us 7 injections, 300, still 5 injections. So we want to remove one type of, we want to get the number of transitions that we're measuring down a bit. And we will do that by going Edit, Refine, Advanced. And we're going to have it remove the heavies for now. So just, not click add, sorry. All you have to do in here is switch this remove label type from nothing to heavy, and that's it. and then you click OK, and those all go away, and now we're down to 600 transitions, and that means if we go File, Export, Transition List, multiple methods, and say that we're willing to accept 300, we can do it in 2 methods. So now 300, that even for modern mass spectrometers, that's a little bit much to get a quantitative assay, but we're really just trying to figure out where these things show up. So if we only get, 4 or 5 points across the peak, that's not a huge problem. So that's what they did. So it did take them 2 methods to measure all these things. And so now we do need to get the iRT peptides in here. And so we can either do it the way we just did it, which is let Skyline put them in. But since, as somebody just pointed out, those aren't the reference transitions, so that means that's not what Biognosys measured. If it wouldn't matter, those are perfectly good transitions, and by our measurements, the best for these standards on our systems. But we want to, since we have SRM data, we want to make sure that we use the transitions that Biognosys use, and we can do that by going File, Import, Document, and then we import this iRT C18 standard. So you just leave your selection up at the top, File, Import, Document, and then just choose iRT C18 standard, and that puts the standard up at the top of the document. And this now should have exactly, this has the transitions that Biognosys measured this is all data from the paper, the original iRT paper. So this is what they measured. And now we can go back to our settings, peptide settings, and you can just choose the retention time bit Biognosys human that we just created. Is everybody with me? And then click OK. And once you do that, you'll see that you get the little clock faces on all the iRT peptides. So that gives you some confidence that you have this set up correctly. The transitions don't matter. The iRT library is just matching peptide sequences with their modifications. So, and in fact, even charge state of the precursor doesn't matter. You could, let's see, do we have any? I think these are all charge 2 precursors, but you could have charge 3 precursors in here too. And it wouldn't matter because a peptide elutes when it elutes, and then it gets ionized afterwards. Okay, so now we have this all set up, and we can import some data ourselves. So let's go File. I'm going to actually save this quickly. File, Import, Results. And we want to just do one new replicate, which we can call training. And then click OK. And then select those 2. And click Open. And then I don't have there's the little graph showing up. And that should import pretty quickly. And then once it does, I see, this should make me feel pretty good. I see fairly well-expressed iRT peptides. You can see that they're expressed twice. And I think actually I can go View, Retention Times, Replicate Comparison, and then I can see both sets of iRT peptides. And I can even right click in here and switch to value retention time, and then I get this line. And we can go through that same exercise of, oh, we did this yesterday, right? The first replicate elutes a little bit earlier than the second replicate. Or yeah, a little bit later. Okay, so that's, but now we also have measurements of all the other peptides. And, you know, we might go through and check. Actually, I'm in total mode. If other people are in total mode, you can right click and choose transitions all. So, you know, we might choose F11 and go through some of these and see if we feel like, did Skyline make good picks? And you can see they're very sharp peaks. These, you know, these are not quantitative peaks here, but they do give us, you can see that generally there's good coelution, and they give us decent measurements of these peptides. Even though if you do shift F11, you can see that we measured a full 40 minutes of retention time, which is why I think these must be poorly, they say 30-minute gradient, but we were measuring 40 minutes. I think these are closer to like a 45-minute gradient. But so there you go. That's we're gonna just assume, like, probably I would certainly consider going through each and every one of these and making sure that I really believe that they captured my peptide of interest. Like this one, probably not. Like I don't know where this AQY peptide is, but it's probably not this. There's I mean, it's you know. Yeah, so I would consider deleting this or actually injecting the heavy. I'm kind of surprised. I would have expected them to do the experiment like this, where if you have heavy labeled peptides, then you should measure those as your training. So I would have expected them, instead of removing the heavy, to actually remove the light and measure a set of heavies. Okay, so now let's go. So we've got measurements of these things. If you go view retention times, view retention times, regression score to run, then you can see this regression plot, and you can see that Skyline picks the best thing to do a regression against is SSR calc. Do people know what SSR calc is? Have I explained it? I probably haven't. So SSR calc is a sequence-specific retention calculator. So it's just taking the amino acids and predicting where they should show up. And so, wow, that's, you know, it's pretty cool that it's done so well. You know, I think it's might be worth checking out these two, which are in the wrong, you know, seem to be in the wrong place. Let's see. So that's one sort of like what I just showed you, and we could maybe see if is there anything else in here that we think it should be a lot earlier, right? So there should be something maybe in here, but I doubt we're going to see anything. Maybe that thing. That puts it right where it's supposed to be. So let's do that correction. This may be a case where the peak is narrow enough, and our windows, you know, our fast cycle time makes it hard to measure. So let's make that correction. Is everybody get there? Did people get there? So what I did was, I'll undo it. I clicked on this furthest outlier thing, and then at 13.9 I found another peak that, to me, like, I can see why Skyline didn't necessarily like it. It's really just sort of a 1-point peak, but it looks like it's got some coelution, and and it shows up exactly where the SSR calc predicts it should show up. So I'm going to go ahead and do that. And then I'll take a look at the next one just by clicking on that point. And this again it's choosing something late. That to me doesn't, somehow Skyline's fooled into thinking that's some coelution. Doesn't look that much like it to me. Let's see if we can find something earlier. Well, maybe this. Let's see, if I click this, it doesn't really get as early as SSR calc is predicting. So maybe this thing. Again, oh yeah, everything is coeluting, extremely sharp peak. Skyline didn't even consider this as a possibility, but we can choose it. This doesn't even have a number over it, which means that Skyline didn't think it was, didn't really notice it as one of the top picks. Maybe because of this. Yeah, I don't know why. I mean, I guess it's small. It's only 900. But we can choose it anyway by putting the cursor below the x-axis and then integrating. And now it shows up right where SSR calc thinks it should be. And then we might also look at a few of these way up at the far end, but probably those are not going to yield anything. Like, yeah, that's probably the right peak. And that's probably the right peak. So anyway, we corrected 2 peaks. And you could imagine wanting to go through all of these and check where they're expected to be versus where they actually show up. And Skyline makes it nice and easy to with its interactive graphs to view this stuff. With directed investigation, what I call directed investigation, you don't need to go through systematically. We haven't gone through systematically. We just kind of picked some things that looked odd. All right, so then let's right-click in this score-to regression plot, and we can actually choose what calculator we want. So currently it's on auto, which means that Skyline will just choose the best calculator for our peptides. Why is the Biognosis human not the best calculator for our peptides? Anyone? Because we haven't trained it yet, so let's choose it and see what it looks like. So if you click Biognosis human, I'm going to undo zoom and pan. You can see that these are all peptides for which we have measurements. But because Biognosis chose negative, I just sort of stick them off to the left side here. I just choose some number lower than anything we actually see. These are the standards, which correlate quite nicely, but all the other peptides haven't been trained. So from Skyline's perspective, this is a terrible calculator for these peptides compared to SSR calc, right? So let's go train them, and then we'll see things get better. So let's go settings, peptide settings, and we'll just go into the edit current calculator. So click on the little calculator button and click edit current. And so you see that there's no actual measured peptides, they're just the standard peptides. And so now we would click add, and then we'll just add results. And you can see that you have options here. You could add from a spectral library. So if you have a spectral library and it's got a bunch of retention times that were measured, you could pull them all into your calculator. You could add from an iRT database. So if you have another iRT database, you could pull those in. And one trick to be aware of is even if you have data where you didn't measure the standards, if you have enough overlap with your existing calculator, Skyline will do regressions against those values and still be able to add to your calculator. So At this point, our only way of bootstrapping this calculator is to have some measurements with the iRT peptides in them, but then we can keep adding to this calculator as much as we want based on overlap. So let's add results, and Skyline says, okay, you had 2 files, the regression R values are 0.999, we've got slopes of 6 and 11 points, and you can click success and look at how well the regressions of the standards in these runs, and then those regressions are then used to map all these values into the iRT. So we click OK, and then it says, do you want to recalibrate your iRT standard? Which is, we have found ourselves, and what you're going to be doing later today is you're going to be using iRTs to just do bulk extraction of DIA data, and in that case we found that we get a lot better, and then you use them for scoring and everything. So in that case we found that recalibrating the iRT standards themselves to your system produces better results. So we get better scoring if we calibrate a calculator to the system, but in this case we'll just say no. So we're leaving our values the same as Biognosis defined them, and there we now have 148 peptides added to our calculator, and we can click OK. And now, this is clearly the best calculator. It suits this data set very well because it was trained on this data set. So click OK. And now you can see Skyline has predictions for all the peptides where it expects them to show up. And they generally show up right in the middle of the peptide because we just trained it that way. All right. So okay, so now let's say so we've got a calculator. Let's say we're going to take this to a new system, or we just changed our column or whatever, and we want to retrain our retention times. If we just wanted to measure a bunch of retention times, we just wanted to, okay, so let's go ahead and save this file, save as iRT human measure. So we'll call it iRT human measure. So we're setting about, we want to actually measure everything, and we're going to edit, manage results, remove the training set. What else do we want to do before we measure? We want to add back our heavies, right? So we would go edit, manage results. Oops, not manage results, sorry. Edit, refine, advanced. And then check add and choose heavy. People with me? Okay. Click OK. So now we're back up to 1,200 transitions. And we might be able to measure them all by SRM in one run. So the first thing we have to do, though, is to get a measurement on our new system, and I sort of forced them to, in the paper, to do it switching from 30-minute, or I think it's 45-minute, to 90-minute. And I think the training data looks big. Huh. Well, we'll try it. Anyway, so this we're going to import this TRID raw. Which should just have a measurement of our peptides on a 90-minute gradient. So we've been working on a 45-minute gradient. We created normalized retention times, which are not in minutes at all. They're just these normalized values. So now we go File, Import, Results, Single Injection, and this TRID thing, which I think just contains the iRTs. Yeah, that's what it looks like. Okay, so you can see that we didn't get measurements for anything but the iRTs. And that's sort of the beauty of the iRT method, is in order to know where all the other peptides are going to fall, all we need to do is measure the iRTs. So in this case, the way we were doing things before iRT was we had to, we would have, that for that rat plasma data set, I think I mentioned we did 5 unscheduled runs or 6 unscheduled runs in order to predict where all the peptides were. And now we can just measure the iRTs once, and now we could predict where everything else is. So if we wanted to now go File, Export, Transition List, we could have a scheduled type transition list that's automatically chosen that because of our iRTs. And we could say, let's see, if we allow 100, what? How many concurrent? Oh, maybe we need more setup. Let's see. Okay, so right now it's saying if I allow 100 concurrent transitions, I need 5 methods. So I'm confused by that. I'm going to quickly, let's go back, cancel, and go to settings, or no, go to view, retention time scheduling. Yeah, wow, okay, so we need to allow, if we have a 5-minute window, which is I think what's set up, then yeah, so yeah, if we have a 5-minute window, we're going to, we're going to have 250 concurrent transitions. I guess that's what they did. So yeah, somebody said they had an instrument that could measure 200 to 300 for quantification, and it looks like this is what they allowed as well. So one more thing is, let's go back to settings, peptide settings. We're not, at this point, we're not allowing it to use measured retention times, which is good. And then we have to take a quick look at this Biognosis human predictor, which is where, oh, it's saying that we want a 10-minute window. So let's say maybe a 5-minute window, and click OK. So we thought that a 5-minute window, 250 transitions would be okay. So we're going to switch to a 5-minute window for around our calculator. And now I think if we go OK, File, Export, Transition List, and we do multiple methods and say that we have 250, well, that's still 2 methods, 260. How high do we have to go to get 270 concurrent transitions gets us a single method. So I guess I know this is what Biognosis did. So we'll see how many points across the peak we see once we import this data. But we could then now say a single method, click OK, and in Documents, iRT, we could call this human And then if we go look at it, you can see that now we have yeah, we're missing headers, as somebody pointed out before. So this is our Q1, Q3, CE, time, window, not sure what that one is, and then sequence, protein, fragment, rank, and isotope, ILT, isotope label type. Okay, so, and we could just import that and run it. And that's what Diagnosis did. The main point being that we were able to schedule everything without prior measurement on this column. Okay, so now we would go and edit, manage results, and remove these results. Okay. And save that. And let's import the final results. File, import results. And there's just one file, and it's this simple. People there? Okay. Open. So, and then now we have measurements for everything. You can see dots beside everything. We could switch to settings, integrate all if we wanted to see most of the dots look green. All the dots look green at this point. And then we could start reviewing the data. Which looks pretty good, for the most part. That one doesn't look that great. We could again do view, retention times, and then regression and score to run. And so now these are where things got measured compared to where they were predicted. So that's pretty, that's pretty good. Everything is picked up right about where it's expected to be in the Diagnosis human. Of course, at this point we did, let's see, what did Diagnosis actually measure? Shift F11. They measured 5-minute windows, right? Or more than 5 minute, like a 6-minute window. So they measured from 11 and 11 point whatever to 17 point whatever. So 6-minute windows. Who knows how to find out how many points across the peak they got? All right, so what you do is anytime you select a transition, Skyline will mark where the actual measurements happen and tell you how many points across the peak. So they're getting 17 points across the peak here, and probably 17 for each transition. This one had 14. This one had 19. So, getting pretty good points across the peak, 20. So I don't, let's see. I guess we can't really, it's not easy to figure out. I guess what we'd like to know is, did they view retention time scheduling? We'd kind of like to know right around here. What are the peptides right around here? Around 30 minutes, which is going to be the most dense. And we could, well, let's see. If we went to view document grid, and chose views peptide RT results, then now we have the predicted time and the actual peptide time, which is, we're going to be pretty close. But if we just sort ascending on predicted time, then we can go down here and find the ones that are around 30. Is that what we said it was? 30? Yeah, 30 is going to be our most dense time. And well, actually, it's interesting that if I want to have clickable peptides, this report didn't actually, I guess maybe was created before we had the links. So I'm going to go to views, edit view, and check peptides and move that up to the top, and then I'll just delete this peptide sequence. And that will give me a clickable column so that when I then go down here to 30, I can now click on these things rather than having to hunt them down. And I can check on, so that looks fairly sharp to me. And the points across the peak, oh, let's still look fine. I'm getting 24. Whoops, that's hard to see, isn't it? So even here where it looks pretty sharp, I'm getting 24 points across the peak. Yeah, that's wild. That does look really sharp, and yet it says I'm getting a lot of points across the peak. 12, I guess, in that case. So any questions? Anybody want me to go back and do anything again, or people basically get IRTs now? I guess well, I guess we can actually just save that document. And then what do we have? Yeah, so here's a document that I created, which let's open that. File, open. So this is an example of how, like, if I wanted to add some yeast peptides, this is a DDA document, which you'll learn about tomorrow. And it's actually just, there's a spectral library that I built here myself. So if I go view spectral libraries, here's my spectral library. It looks like it's got 683 peptide 683 yeast peptide spectra. I can click on this ... button to see. Oh, it was done before we had that. Okay, so anyway, so we have 572 unique peptides. So if we wanted to then, and in this case I had the, we have we can see the redundant ones. So here this was actually detected in 3 different times in 2 different runs. Yeah, so you can see that this spectral library was built out of 2 different files. And so then, and it contains I had them inject the iRTs, so now we can go add these to our library just by going settings, peptide settings, click on the calculator, click add, whoops, I'm sorry, edit list. Now I need to edit the Biognosis human library, and I can click add from a spectral library, and I choose that one, which is my current one. Click OK, and then Skyline says, hey, okay, I can do that. You have a 0.997 R for your iRT standards, which are in here. Looks like one of them showed up in a weird place, but I've got enough other ones, so this one just got kicked out. So you see that the regression is done with 10 points instead of 11 points. And then what is it telling me? 3 iRT peptide values calculated from chromatogram peaks will be kept, and newer iRT values from MS. So these are 3 peptides that were already, so apparently there are 3 peptides that appear both in yeast and in human. And what it's telling me is that, hey, I'm going to keep the ones that you trained on chromatograms and not pick up. At this point, I'm importing the library, and I'm just using the spectrum times. So if I click OK and say, no, I don't want to retrain the iRTs, then you can see now I'm up to 706 peptides. So this is a way that you can build up your iRT library so you have more and more stuff. So there are now more automatic ways that actually, when you build a bibliospec library, if it contains iRT values, one of the easier ways to get an iRT calculator now, so I'm just going to cancel out of that. One of the easier ways to get an iRT calculator now is to, when you build a library, there's this, if you tell it that you are using one of these iRT standards, Skyline will just build an iRT library into your spectral library. And so we've got Biognosis. Pierce is what our lab uses a lot. We use the PRTC, the retention time calculator from Pierce Thermo. And SciEx has their own. I think Replical maybe comes from Waters, Sigma, Aldrich. And then there's also this ApoA1. That's what Andy was talking about yesterday. It's a 15 labeled ApoA1 that can be used both as a retention time standard and as a normalization standard that he was using. And then the CIRT, there's a paper, it was a collaboration between the Van Eyck and Aerosolve labs about using endogenous peptides that are conserved across eukaryotes. So those are all things that Skyline knows about, and if you build a spectral library, you can just get an iRT library by telling it that you want to do it based on those standards.